Hi friends, when we started our YouTube channel, one viewer asked about endotoxin challenge study for tunnel validation. At the time, if we had discussed about it directly, some viewers may not have understand the BET basic concept and fundamental key concept. For that reason, we discussed BET basic concepts in our previous videos. Today, we are going to discuss what is the endotoxin challenge study for tunnel validation. This video is very interesting and very simple. If you are first time here, please subscribe our channel. Welcome to PHARING, a channel of pharmaceuticals. I am your Shaktivel. Before drug filling, all vials are depyrogenated using a depyrogenation tunnel. This depyrogenation tunnel is a specialized piece of equipment in pharmaceutical industry used to remove or destroy the endotoxin from the containers. This endotoxin challenge study is performed for depyrogenation tunnel to prove that the tunnel remove or destroy the endotoxin effectively under the normal operation condition. How is an endotoxin challenge study performed? In simple, how can we say known concentration of endotoxin spiked onto the vial and passed through the depyrogenation tunnel. After completion of the processing, the endotoxin level of exposed vials are measured with Limulus amibosate lysate test. If the reduction of endotoxin level meets the required log reduction, the challenge study is considered passed. So this is a simple explanation about endotoxin challenge study. Now let us see the procedure of endotoxin challenge study. We already discussed known concentration of endotoxin challenged or spiked onto the each vial. Normally, for better approach, each vial need to be challenged with 10,000 EU per vial. Why 10,000 EU? 10,000 is the highest load of challenge to prove the worst case contamination for this study. If an entire CSE control standard endotoxin vial contains 2 lakhs EU per ml, means it should be diluted up to 1 lakh EU per ml. For example, 0.75 ml stock solution added to 0.75 ml endotoxin free water. Finally, it is converted to 1 lakh EU per ml. This is a stock solution for spiking into vials. For example, here we are taking 9 vials. Based on the validation approach, number of vials varied. So, transfer the 0.1 ml to all these 9 vials. After spiking 0.1 ml of known endotoxin concentration, these 9 vials are challenged with 10,000 EU. Then allow these vials to air dry to ensure the proper endotoxin distribution. This process is called preparation of endotoxin challenge vials. So now we have a 9 vials with 0.1 ml of known concentration of endotoxin 10,000 EU. After drying, these all vials are subjected to depyrogenation process except one vial. The remaining one vial is considered as a positive control. After completion of the depyrogenation process, the exposed vial or baked vials and remaining one positive control vials are analyzed. First, we need to prepare the standard curve using unbaked or positive control vial. We know the positive control vial contains 10,000 EU. So, add endotoxin free water into the vial and vortex well 10 to 15 minutes. Now, the vial contains 10,000 EU per ml. And in this test, we are using the lysate sensitivity 0.125. So based on the 0.125 lysate sensitivity, we need to prepare a standard curve as shown in this image. So 2 lambda 0.25, lambda 0.125, lambda by 2 0.0625 and lambda by 4 0.03125. At the same time, reconstitute the exposed or baked 8 vials with the endotoxin free water, 1 ml endotoxin free water and vortex for 10 to 15 minutes and reconstitute the lysate also based on the COA. Now we prepared the standard curve and prepared the 8 samples, everything. Our samples are ready for incubation. For negative control, 0.1 ml of endotoxin free water mixed with 0.1 ml of lysate and we have a 8 baked exposed vials. Transfer 0.1 ml of sample from each tube individually to each 8 fresh tubes and add 0.1 ml of lysate to all tubes. For each vial, we need to use 2 tubes. So, totally 16 tubes. And standard curve 0.1 ml of 2 lambda plus 0.1 ml of lysate. 0.1 ml of lambda plus 0.1 ml of lysate. Same follow up to lambda by 4. Incubate these all tubes at 37 degrees Celsius for 1 hour. We incubated negative control tube, 8 sample tubes and control curve 2 lambda, lambda, lambda by 2 and lambda by 4 tubes. This is a common setup. In some organization, based on the SOP, they prepared separate standard curve for lysate verification and they are incubating water positive control, etc. But this is a common. After the completion of incubation, all tubes are inverted to 180 degree angle for result observation. Negative control and sample tubes should not showing any clot. 2 lambda and lambda showing a clot and lambda by 2 and lambda by 4 showing no gel clot formation. And the reduction of endotoxin level of log calculated by the below formula. Endotoxin recovery of unbaked vial means positive vial last dilution which is positive into lambda into reconstitution volume, that is A. Endotoxin recovery of baked exposed vial is equal to first dilution which is negative into lambda into reconstituted volume, that is B. First one, endotoxin recovery of unbaked positive control vial. We are challenging 10,000 EU. So 10,000 divided by 0.125 is equal to 80,000. Last dilution which is positive 80,000. Lambda 0.125 into reconstituted volume 1 ml. So total 10,000 EU. So the second formula, endotoxin recovery from exposed, baked vial is equal to first dilution which is negative, 10,000 to 3 lakh reduction 10 EU divided by 0.125 is equal to 80. So 80 into 0.125 lysate sensitivity into reconstituted volume 1 ml is equal to 10. And the another formula, minimum log reduction is equal to log A minus log B, means log 10,000 minus log 10. Log 10,000 is equal to 4, log 10 is equal to 1. So 4 minus 1, 3. Finally, we got the required log reduction 3. The endotoxin challenge study meets the challenged requirement. This is a overview of endotoxin challenge study. If you are like this video, please subscribe our channel and click the bell icon for future videos. Bye.